Okay, in the previous class that I was discussing about mass difference in the mirror nuclei, right? Yes, is it audible now? Yes. Hello. Yes.
Yes,
Okay.
yes.
See, so in the previous class that I was discussing about mass difference in the mirror nuclei between mirror nuclei. That is delta m between one is Z1, another one is Z2. The difference between these Z1 and Z2 will be always plus or minus 1 term. Okay. That we discussed in the yesterday's class. There I got that mass difference as 2 times of EC Z1 minus 1 e to the power of 1 by 3. Okay. So keeping this point in our mind, so let us discuss about how that radius can be calculated. From this expression, we know that see, um, here if you know the difference between their masses, then mass difference between MP and Mn, you almost is if you treat Mn and MP both are nearly same, then I get the delta M as so neglecting the mass difference between the proton and neutron by neglecting mass difference between mass difference between proton and neutron, we get the delta M as the delta M is equal to 2 times of AC divided by e to the power of 1 by 3 into only Z1 minus 1. So Z1 is the initial. Which one is greater atomic number other the Z1 to okay, because here Z1 we treated that is greater than Z2 here, right? See, as we know that uh, EC in this case EC is equal to that I have written already that 3 by 5 times of 1 by 4 pi epsilon e square by r naught, where this from this relation, and already we know that the radius relation is radius of the nucleus is given by r equal to r naught into e to the power of 1 by 3. So by using these two equations, we can calculate that radius of the nucleus. That is another using this part also. So that is AC 3 by 5 times of pi. So AC is equal to 3 by 5 times 3 by 5 times 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught e square by r naught e square by r naught. So using these two equations, we can calculate the radius using that E value, that's atomic mass value. Okay. Then see, we know that delta M is given by see, there we got that AC. What is the AC relation? That is EC. That is the energy of the Coulomb force. So it's the energy of Coulomb forces. Coulomb forces, right? So what we wrote that EC is equal to EC we used to write that is AC into Z into Z minus 1 Z into Z minus 1 divided by e to the power of 1 by 3. Instead of this, if I write like this, if we write like AC is equal to uh, AC into Z square divided by e to the power of 1 by 3. Means if the atomic number is more, if Z is very very higher than 1, then we can treat that one as Z directly. AC is equal to so EC is equal to AC Z square divided by power 1 by 3. And by using the same thing, if you take the difference by using treating this term, if you take mass difference between the nuclei, mirror nuclei, delta m becomes um, for this particularly if I treat because ಈ ತರ ಟ್ರೀಟ್ ಮಾಡಿದೀವಿ ತಿಳ್ಕೊ ನೀವು ಏನು ಬಂದಿರ್ತದ ನಮ್ಗೆ mass difference we get like this z1 minus 1, but if I treat that one as z square, then I get mass difference as different. Delta m now becomes there is mp minus mn mp minus mn. Wait a second. So the delta m for this part especially. for this part, that mass difference between the mirror nuclei becomes mass difference delta m becomes that is equal to mp minus mn plus is AC times of actually AC times of what a to the power of 1 by 3. So we write if you take the Z1 and Z2 on different molecules, means ಎರಡು nuclei ತೊಂದ್ರೆ ಅದು Z1 square minus Z2 square ಆಗ್ತದೆ. Because we are going to take the difference. All other terms other than Coulombian forces are going to get cancel out each other. Okay. But here this term remains like this. If you solve this one properly, what I get here is delta m is equal to mp minus mn, mp minus mn plus times. So here can I write this one as a plus b into a minus b? AC divided by a to the power of 1 by 3 into z1 minus z2 into z1 plus z2, isn't it? So if you treat this, see, we know already that z1 minus z2 is going to be 1, right? So if you treat this as mirror nuclei, according to the mirror nuclei, what we write, its protons will be equal to one's protons will be equal to number of others neutrons, right? So see here, we just replace this one in terms of A, that is, say we know that z1 minus z2 is equal to 1. In case of mirror nuclei, if I treat this one as z1 with a1, then y is z2 with a2. We know that, so if there is z1 is number of protons, means so n1 is the number of neutrons, here z2 is the number of protons, then n2 are the number of neutrons. We know that these are equal, so these are equal, right? In case of mirror nuclei, because protons of one nuclei is going to be equal to neutrons of another one nuclei. I will replace this z1 with n2. If I replace this z1 is equal to n2, then I get z1 as z1 equal to uh, z1 is also equal to a minus z2, isn't it? So can I write this z1 is equal to a minus n2? Because now as it is equal to number of neutrons in the second nuclei, then I can rewrite, because this n2 is equal to a minus of z2 second nuclei. Therefore z1 can be rewritten as a minus z2. Then this z1 plus z2 becomes a z1 plus z2 becomes what happens? Z1 is given by a minus z2. Okay, then plus z2. Then I get this z1 plus z2 is equal to just a only. Therefore z1 plus z2 is given by a. This is clear. In case of mirror nuclei, this is applicable only in case of mirror nuclei. So this is applicable for mirror nuclei. Mirror nuclei. Okay. So as the protons of the first nuclei is equal to number of the neutrons in the second one, so second one is equal to first number of the protons in the first one. Therefore, by taking that content, then I can replace that z1 is equal to a minus z2. By replacing that one in terms of z1 plus z2, I get a. And n1 now n1 becomes, n1 can be written as n1 is equal to, I can rewrite it as z2 here. So n1 is equal to z2. And by replacing in the above term this energy, that mass difference equation, what I get here, delta m that is mp minus mn, right? Plus AC divided by, already we know that it is a power 1 by 3. Then if I replace all these terms, this z1 minus z2 becomes a, z1 plus z2 becomes a. What about z2 minus z2, z2 minus z1, z1 minus z2, that is 1. By taking this value and this value, which is here, this one, by replacing z1 minus z2 with 1 and z1 plus z2 with a, then I can rewrite this term as a into just 1, because it is a z1 plus z2, this is z2 plus z1 minus z2. Therefore by calculating this one again, what I get here, mp minus mn plus times of AC term. So this becomes, it becomes a to the power 1 minus 1 by 3, that becomes a to the power 2 by 3. So can I write that one as directly as e to the power of 2 by 3 here? So this is what the energy equation if the Z1 and Z2s are greater than 1. So this is applicable for if Z1 is greater than 1 or Z2 is greater than 1. Is that clear? You can take the Z2 or Z1 or greater than 1. For that part, we can rewrite that it's not a mass defect, it's a mass difference of the mirror nuclei. Mass difference of mirror nuclei. Mirror nuclei. Say if you calculate this part, what is that? MP minus Mn is okay. Then see, if you look at this mass difference is directly proportional to this mass difference is proportional to a to the power of 2 by 3. If you plot the graph for like this, that is a to the power of 2 by 3 versus delta m. So what is this graph becomes? Graph is a straight line because you can treat this part as like some constant plus some slope into that x-axis and this becomes y-axis. For x-axis ಒಳಗೆ ಏನದ a to the power of 2 by 3 ಐತಿ, y-axis ಒಳಗೆ delta m ಅದ, right? By taking this, the graph becomes like this. So graph will be here. So whether mass of the proton is heavier than mass of the neutron is heavier, depending on that, the slope differs here. MP minus M or Mn minus MP, that is. Which one is greater? Mn is greater or MP is greater? Actually, Mn is greater than MP. Little bit, ಸ್ವಲ್ಪ ಭಾಳ ಏನಲ್ಲ. Therefore, graph ಎಲ್ಲಿಂದ ಹೆಂಗೆ ಬರ್ತದೆ ಅಂದ್ರೆ ಇದು straight line. This is straight line only, but just the intercept ಬರ್ತದೆ. That intercept is now defined as here like this. So this intercept is nothing but Mn minus MP, sorry, MP minus M. Correct? So this is what the graphical mass difference of the mirror nuclei versus mass number. Mass number. And similarly, we can calculate the Coulombian energy difference between the mirror nuclei. So they may ask this also. Mass difference we calculated. Right? Here we got the mass difference. Then Coulombian energy difference between the mirror nuclei. It is Coulombian energy difference between mirror nuclei. Mirror nuclei. If you take the delta that is AC, just AC depends on what the part. So just we got here, right? What is that AC? AC we know this term, right? So by taking this one, then either generally for heavy nucleus, we will rewrite AC as AC Coulombian energy of the any nucleus is given by AC divided by a to the power of 1 by 3 into Z square. Alright. Then if I take the energy difference, the energy difference becomes delta E becomes delta EC is equal to, then it becomes constant AC divided by e to the power of 1 by 3 into Z1 square minus Z2 square. Z1 square minus Z2 square. This is what the energy term. Similarly, by replacing that part, what we got there, that if I take this one, Z1 plus Z2 is equal to 1, Z1 plus Z2 is equal to A, Z1 minus Z2 is equal to 1. By taking these two values, you can rewrite that delta energy difference in the mirror nuclei, that becomes AC divided by e to the power of 1 by 3. This becomes A into 1. Then that energy difference becomes AC is equal to AC into e to the power of 2 by 3. May ask, so energy difference between the mirror nuclei is proportional to e to the power of 2 by 3. Delta EC is directly proportional to e to the power of 2 by 3. Done with this? Is that clear all? So Just for the mirror nuclei, we can calculate the mass difference. And by using that mass difference and all the terms, we can calculate the radius of that one. Then energy of the Coulombian forces. Then we can calculate its mass difference. Then there is a plot for mass difference versus e to the power of 2 by 3. It's not just only e to the power of 2 by 3. So this is delta M. And there is a Coulombian energy difference. And just look at this, semi-empirical mass formula. Semi-empirical mass formula. Just I will rewrite that one. In terms of atomic mass, I will write. Okay. Then mass of any atom is given by, that is M having Z and A. That becomes times of mass of the hydrogen plus A minus Z times Mn. So minus times binding energy we used to write, right? But here I will do? I will expand that binding energy type. That is volume energy part, EV into E. It is actually plus. Because of its minus sign of the binding energy, we get minus to multiply with all the terms. And minus of AV, A, and plus times of AS, e to the power of 2 by 3. With surface energy term depends on mass number as e power 2 by 3. Then plus Coulombian force AC into, write that one as Z into Z minus 1 divided by e to the power of 1 by 3. This Coulombian force. The next part is asymmetric part. So how do you write this asymmetric part? The asymmetric part becomes, it is AA plus times of AA into that is A minus 2Z whole square divided by A. Next is plus or minus, that actually it becomes minus or plus. Isn't it? So generally that was minus times of binding energy. So if I rewrite that the binding energy properly, then minus will be multiplied inside. Then I get this becomes minus plus minus minus plus AP. That is binding energy term, right? It is A to the power of P by 4. Remember all individual terms. They may ask what is the volume energy depends, how that surface energy depends, how the Coulombian energy, how it's asymmetric energy and pairing energy. See, if I rewrite the same expression like this, mass and A, see, if you look at only coefficients of Z power 0, look at the coefficients of Z power zeros. Here are the Z power 0 coefficients. See, here there is no dependency on Z. This part there is no dependency on Z. And this part is also there is no dependency on Z. Right? So all of the terms here we don't have any Z dependency. Then Z power 1 dependencies are there here. Z power 1. Then here also only Z power 1. Then here we can expect Z square. We can expect the Z square from this. And even here also Z dependency is also there. Z square dependency is also there. Then there is no dependency of Z here. But, so here I will rewrite the same expression. Once you look at this, I will rewrite as alpha into just A plus beta into Z, then plus gamma into Z square plus minus or plus is delta. Here what is this exactly? Here alpha means alpha is going to be Mn minus AV plus times of AS divided by e to the power of 1 by 3, then plus e to the power of only A term. Let's look at the above expression. Here alpha is actually the coefficient of A. In the above expression, wherever there is A, if there should not be any dependency on Z. Here it depends on Z power 0. So these are Z power 0 coefficients and A to the power of 1 coefficient. A coefficient and Z to the power of 0. Where we get, see, here A is there, Mn is there. There is no dependency of Z individually. Here there is no Z dependency. Here is no dependency. And another one term is A. If you look at this, if you expand this term, you are going to get that one as only A term. Because after expanding this, what I get here? actually A into A square minus of 2 times of AZ, sorry, 4 times of AZ, then plus 4 times of Z square divided by A I get. Then if you look at the coefficients, this A get cancels here. The coefficient of A is going to be only AC. Here Z dependency is there, here Z square dependency is there. That by removing all the parts individually, separating out all the terms individually, then we get that alpha as this one. This only depends on Z power 0 and A power 1. Now look at this Z coefficient is treated as beta. This beta is actually equal to the mass of the hydrogen minus mass of the proton, then minus AC divided by A to the power of 1. If you expand the whole if we expand this whole then we get like this. See here all beta. Beta means Z dependency. Z dependency wherever where there is Z dependency. See, look at this part is Z dependent. Then this part is also Z dependent. Then here is Z dependent. Then here also Z dependent. So that I have written already. See, so these are the terms. And if you look at the Z square dependency, that gamma becomes here, that is AC divided by A to the power of 1 by 3 minus 4AA plus 4AA divided by A, where this depends on Z square. Here this depends on, this is the coefficient of Z power 1. This is Z square coefficient. Then if you look at this delta, delta is actually pairing energy term, then the delta directly becomes AP divided by, this delta becomes AP divided by A to the power of 3 by 4. If you just look at the expression which depends on Z, then we get this expression. Right? Let's look at this expression. I'll rewrite the same expression here. That is, mass of the any nucleus can be written as, that is, alpha with A, alpha into A plus beta into Z plus gamma into Z square, then minus plus delta. See, this expression is actually a quadratic equation as a function of Z. Isn't it? This expression is a quadratic equation as a function of Z. Therefore, this expression represents a parabola. Because all quadratic equations are going to represent a parabola. Because it is a quadratic term. Quadratic term of Z. Therefore, this expression explains about parabola. It's a parabolic equation. So, mass of the isobars, especially in terms of isobars, we can define. So, from this equation, we can define that mass of the isobars varies in a parabolic nature. Mass of isobars varies in parabolic nature. In parabolic nature. So what do you mean by isobars? Isobars means, bar means same number of, different number of atomic masses. No? What is that? Isobars means same Z, same A. Now check once. Is it same A?
Same.
Yes. Same A, different Z. Right? Same A, different Z. If you look at the different Z values, I am going to get that those curves as parabolic curves. So that is what the Z value. Okay. The most stable isobar will lie at the vertex. So especially how to define this parabolic graph? Parabolic graph will be like this. Parabola. Right? So which is vertex here? This part is called as a vertex. We define this one as a vertex part. So therefore, remember the most stable isobar. By using this expression same, what is that? By using the semi-empirical mass formula, we can calculate the most stable isobar. So there's another one point I will tell what exactly the most stable one. Most stable isobar will lie at the vertex of the parabola. And do you know the condition for the most stable isobar? Condition for most stable isobar is that is, see, the graph ಹೆಂಗಾಗತ್ತದ ಗ್ರಾಫ್ ಏರಿಯಾ ಹಾಕೋತ ಹೊಂಟది. So one part to another part ಹಿಂಗ್ ವೇರಿ ಹಾಕೋತ ಹಿಂಗ್ ಹೊಂಟది. So if you look at this graph, ಯಾವುದೋ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ದಾಗ ಯಾವುದು ಮಿನಿಮಮ್ ಪಾಯಿಂಟ್ ಅನ್ನ ಕೊಡ್ತಿರ್ತದೆ, ಎಕ್ಸ್ಟ್ರೀಮ್ ಪಾಯಿಂಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಅದಕ್ಕೆ ಮಿನಿಮಾ. ಈ ಗ್ರಾಫ್ ಒಳಗಡೆ ಮಿನಿಮಾ ಪಾಯಿಂಟ್ ಯಾವುದು ಇದಾರಿ. ಮಿನಿಮಾ ಮೀನಿಂಗ್ ಏನು? ಮಿನಿಮಮ್ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ಯಾವುದೋ ಫಂಕ್ಷನ್ ಇರಲಿ ಅದ್ರ ಮಿನಿಮಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದ್ರಿ ಅಂತಂದ್ರೆ ನಮ್ಗೆ ಏನ್ ಸಿಗ್ತದೆ, ಅದು ಅದ್ರ ಫಸ್ಟ್ ಡೆರಿವೇಟಿವ್ 0 ತಗೋತೀವಿ. ಅದಕ್ಕೆ this mass is a function of z. If you take the dou m divided by dou z for particular mass number, that is equal to be 0. Zero calculate ಮಾಡಿದಾಗ ನಿಮಗೆ ಏನು ಬರ್ತದೆ ಅದ ವ್ಯಾಲ್ಯೂ. So here we have that expression, right? So what is that? ಅಂದ್ರೆ ಅದ್ರದ್ದು ಮಾಸ್ ಇಕ್ವೇಷನ್ ಕೊಟ್ಟಿರ್ತಾನೆ, ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ರಿ. ಆ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ z equal to ಏನು ಬರ್ತದಲ್ಲ, ಅದು ಯಾವತ್ತೂ ಏನಾಗಿರ್ತೈತಿ, ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಆಗಿರ್ತೈತಿ. Once look at this expression, I got that is m z a. So this, if you see, this expression is alpha a with beta times of z, then plus gamma times of z square minus plus beta. So that is delta. If you differentiate this dou m divided by dou z, what I get here? Dou m divided by dou z. First term becomes 0. Second term becomes only beta. And third term becomes 2 times of gamma z, then again 0. This is always already equal to, if I make this one as 0, so to get the most stable one, I'll put that equal to first derivative is equal to 0. So what I get? I got that this term, that is beta plus 2 times of gamma into z. Where z I will treat this one as z naught. So this tells about the most stable one, stable nuclei. Atomic number of most stable nuclei. This is equal to 0. What I get here? Z naught becomes, z naught is equal to minus times of beta divided by gamma. This is the term here we get. It's a most stable nuclei. And if you look at this parabolic graph, I will write the parabolic graph here. So in case of depending on the nuclei, whether this nuclei is a odd nuclei, whether it is even nuclei, this parabolic graph varies. So we define this one 2 types. So let me take that is case 1. The case 1 is when A is odd. The nuclei is odd nuclei. So odd nuclei, how do you define this odd nuclei? There are 2 kinds of odd nuclei. One is even z, odd n. That is also odd. Then if you look at this even n in odd z. So in these two, in both the cases, what about the delta term? These 2 cases, what about the delta term here? Delta is treated as 0 because there is no pairing. If it is completely odd or completely even, then we define that one as delta term is going to be calculated. But here delta is equal to 0. What is the expression for the mass expression? That is mass of the nuclei in terms of alpha, beta, gammas, alpha times of A plus beta times of Z plus gamma times of Z square. So delta is 0 for these type of nuclei, even Z, odd n, even n, odd Z. Okay. Then if you plot the graph for this, then we get for this see, if the delta is plus or minus, if the delta is finite value, then we get double parabola. It's 2 parabolas. But here we get only 1 parabola because it's a perfect quadratic equation. There is no plus or minus term. For this plus or minus term, we get double or more than 1 parabola. because of this plus or minus term. Once it increases, once it decreases. Okay. So plus ಬರ್ದಾಗ shift ಆಗ್ತದ್ರಿ ಪ್ಯಾರಾಬೋಲಾ above, ಮೈನಸ್ ಬರ್ತಿದ್ವಿ ಅಂದ್ರೆ below shift ಆಗ್ತದೆ ಪ್ಯಾರಾಬೋಲಾ. ಅದಕ್ಕೆ ಈ ಟರ್ಮ್ ಅಲ್ಲಿ ಡೆಲ್ಟಾ is equal to 0 ಅದ. So there is no point of dealing with delta here. Therefore we get only one parabola. So ಪ್ಯಾರಾಬೋಲಾದ ಏನು ಪ್ರಾಪರ್ಟಿ ಗೊತ್ತೇನ್ರಿ, ಈಗ ಯಾವುದೋ ಒಂದು y equal to some ax square ಬರ್ದಿರ್ತೀವಿ, ಪ್ಯಾರಾಬೋಲಾ ಹಿಂಗೆ ಕೊಟ್ಟಿತ್ತು ax square plus c ಬರ್ದಿದ್ವಿ ಅಂದ್ರೆ ಅದ ಪ್ಯಾರಾಬೋಲಾ ಏನಾಗ್ತೈತಿ, ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಮ್ಯಾಲ್ ಶಿಫ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಸಿ ಪಾರ್ಟ್ ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್ ಬರ್ತದೆ. ಇಲ್ಲಿ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಬರ್ದಿದ್ವಿ ಅಂದ್ರೆ ಹೆಂಗೆ ಬರ್ತದೆ ಗೊತ್ತೇನ್ರಿ, ಈ ಪ್ಯಾರಾಬೋಲಾಗಳು ಎರಡು ಬರ್ತಾವೆ, ಒಂದು ಅಪ್ ಮ್ಯಾಲ್ ಶಿಫ್ಟ್ ಆಗಿತ್ತು, ಇನ್ನೊಂದು ಬಿಲೋ ಶಿಫ್ಟ್ ಆಗಿದೆ. ಅದಕ್ಕೆ ಡೆಲ್ಟಾ ಟರ್ಮ್ ಸಂಬಂಧ ಏನಾಗ್ತೈತಿ, ಪ್ಯಾರಾಬೋಲಾಸ್ get more than one parabola. So as this delta is equal to 0 here, there is no need to take more than one parabola. Okay. Here for this particularly, if the delta is equal to 0, we get parabola like this. So if you plot this one as m of ZA, and here in along y-axis, if I take that, then I get the parabola like this. Then I told that vertex means this lowest point is called as a vertex. Okay, this lowest point is called as a vertex. At this point, the z will be always equal to z0. Here z0 is given by, I have already given that z0 is equal to, so that will be the most stable one. ಯಾವಾಗಲೂ ಯಾವುದೇ ಕರ್ವ್ಗೆ ಮಿನಿಮಮ್ ಪಾಯಿಂಟ್ ಎಲ್ಲಿ ಸಿಗ್ತದ ಅದು ಅದರ ಫಸ್ಟ್ ಡೆರಿವೇಟಿವ್ 0 ಇರ್ತದೆ. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಒಳಗಡೆ ಏನು ಜಡ್ ಅದ ಆ ಜಡ್ಗೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್. ಸೊ ರಿಮೆಂಬರ್, ಸೊ ಯಾವುದೇ ಕರ್ವ್ ಇರಲಿ, ಸೊ ಈ ಥರ ಕರ್ವ್ ಇತ್ತು ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ಗೆ ಏನಂತ ಕರಿತೀವಿ, ಮಿನಿಮಮ್ ಪಾಯಿಂಟ್. ಮಿನಿಮಮ್ ಪಾಯಿಂಟ್ ಒಳಗೆ ಯಾವುದೋ ಫಂಕ್ಷನ್ ಇರಲಿ, ಆ ಫಂಕ್ಷನ್ ಡೆರಿವೇಟಿವ್ ಏನಿರ್ತದೆ ರೀ, ಫಸ್ಟ್ ಡೆರಿವೇಟಿವ್ ಆಲ್ವೇಸ್ 0 ಆಗಿರ್ತದೆ. z equal to where it is going to be z. ಒಂದು ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ z ವ್ಯಾಲ್ಯೂ ಇದ್ದಾಗ ಅದು ಮಿನಿಮಮ್ ಆಗಿರ್ತೈತಿ, ಎರಡು ಸೈಡ್ ಕಡೆ ಹೆಚ್ಚಿರ್ತದೆ. ಈಗ ನಾವೇನಂತ ಕರಿತೀವಿ, ಮೋರ್ ಸ್ಟೇಬಲ್ ಒನ್. z is equal to, that is our target, minus beta divided by 2 gamma, minus beta divided by 2 gamma. So that is the term. Then see here, if you look at this, if I go on increasing the what is this z value, if I go along the plus sign and if I go along the minus sign, okay. More remember, this is the most stable nucleus, isobar. Most stable isobar. Why are we going to define this one for the isobar? For the same A, we are going to look at the different jets. Different jets will very jet ಗಳು ಎಲ್ಲೆಲ್ಲ ಆಗ್ತವೆ. Then if I go on increasing higher than z naught ಕಿಂತ ಹೋದ್ರಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಬರ್ತದೆ ಗ್ರಾಫ್, ಹೌದಾ? ಸೊ ಈ ತರ ಗ್ರಾಫ್ಗಳು ಬರ್ತಾವೆ. ಲೋವರ್ ಲೆಸ್ ಸ್ಟೇಬಲ್, ಎರಡು ಕಡೆ ಏನೇನು ನಾನು ಪ್ಲಾಟ್ ಮಾಡತ್ತಿಲ್ಲ, ಈಗ ಲೀಸ್ಟ್ ಸ್ಟೇಬಲ್ ಅದು ಕಂಪೇರ್ಡ್ ವಿತ್ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಐಸೋಬಾರ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ದೇ ಆರ್ ಲೆಸ್ ಸ್ಟೇಬಲ್. Therefore here we get the z as, see here, so this point is can be defined as, this point is one defined, here is also defined. So can I define this point as like, so this point is z0 plus or plus 1, this is going to be z0 plus 1, this point is going to be z0 plus 2, and so on increases. Then if you look at this point, what I get here is z0 minus 1. If you look at this z0 minus 2, so like this it goes. So if you vary the atomic numbers, automatically that graph will be appeared like this for in the particular atomic mass. So it is defined this one as a isobar. For even is odd A, if the A is odd means A is odd, here numbers are not odd, protons and neutrons are not odd, complete A is odd. A ಯಾವಾಗ ಆಡ್ ಆಗ್ತೈತ್ರಿ, z ಆಡ್ ಇರಬೇಕು ಅಥವಾ n ಆಡ್ ಇರಬೇಕು. ಒನ್ ಅಂಡ್ ಆಡ್ ಎರಡು ಆಡ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ನಮಗೆ ಆಡ್ ಟರ್ಮ್ ಬರ್ತದೆ. ಅದ್ರ ಸಂಬಂಧ ಯಾವ್ದಾದ್ರು ಒಂದು ಆಡ್ ಇದ್ರು ಕೂಡ ಇವು ಆಡ್ ಎ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ ಐಸೋಬಾರ್ ಒಳಗಡೆ ಯಾವ್ದಾದ್ರು ನ್ಯೂಕ್ಲಿಯೈ ಅದ್ರದ್ದು ಅಟಾಮಿಕ್ ಮಾಸ್ ನಂಬರು ಆಡ್ ಇತ್ತು, ಅದಕ್ಕೆ ಗ್ರಾಫ್ ಪ್ಯಾರಾಬೋಲಾ ಓನ್ಲಿ ಒನ್ ಬರ್ತೈತಿ. ಒನ್ ಇದ್ರೆ ಏನಾಗ್ತೈತಿ ನೋಡಿ. ಸೊ ರಿಮೆಂಬರ್, ಮೋರೋವರ್ ಇಲ್ಲೊಂದು ಇನ್ನೊಂದು ಟರ್ಮ್ ಏನಂತಂದ್ರೆ ಈ Z naught is the most stable one ಅಂತ ಹೇಳಿದೆ ನಿಮಗೆ. ಓಕೆ, ಈ ಲೆಫ್ಟ್ ಸೈಡ್ ಇರುವಂತ ರೈಟ್ ಸೈಡ್ ಇರುವಂತ ಟರ್ಮ್ಸ್ಗಳು ನೋಡ್ರಿ. ಗೋ ಫಾರ್ ದಿಸ್, ಈ ನ್ಯೂಕ್ಲಿಯೈ ಹೋಲ್ ನ್ಯೂಕ್ಲಿಯೈ ಏನ್ ಮಾಡ್ತೈತಿ, ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೈತಿ ಇವತ್ತು. ದಿಸ್ ರೈಟ್ ಸೈಡ್, ದಿಸ್ ಎಲಿಮೆಂಟ್ ಟ್ರೈ ಟು ಗೆಟ್ ಸ್ಟೇಬಲ್, ಅನ್ಸ್ಟೇಬಲ್ ಅದ. ಈಗ Z naught ಬಂದು ಸ್ಟೇಬಲ್ ಆಗ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಅದು ಡಿಕೆ ಆಗ್ಬೇಕು, ಯಾವುದೋ ಒಂದು ಪ್ರೊಸೆಸ್ ಡಿಕೆ ಆಗ್ಬೇಕು. ರಿಮೆಂಬರ್, ದಿಸ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗೋ ಥ್ರೂ ದ ಬೀಟಾ ಪ್ಲಸ್ ಡಿಕೆ. ಈ ಕಡೆ ರೈಟ್ ಸೈಡ್ ಇರುವಂತ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಏನದಾವಲ್ಲ, ಬೀಟಾ ಪ್ಲಸ್ ಡಿಕೆ ದಿಂದ ಡಿಕೆ ಹಾಕೋತ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ಸ್ಟೇಬಲ್ ನ್ಯೂಕ್ಲಿಯರ್. ಸೊ ಬೀಟಾ ಪ್ಲಸ್ ಡಿಕೆ ಮಾಡ್ತೈತಿ, ಸ್ಟೇಬಲ್ ಕಡೆ ಬರ್ತೈತಿ. ಬೀಟಾ ಪ್ಲಸ್ ಕಡೆ ಬರ್ತೈತಿ, ಇದು ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತೈತಿ. ಆಲ್ ದ ನ್ಯೂಕ್ಲಿಯರ್ ವಿಚ್ ಆರ್ ರೈಟ್ ಸೈಡ್ ಆಫ್ ದ Z naught are going to get to beta plus decay. Okay. Then the elements which are at the left side, ಇಲ್ಲಿರುವಂತ ಎಲಿಮೆಂಟ್ಸ್ ಅವು ಕೂಡ ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾವೆ, ಬಿಕಾಸ್ ಇವು ಕೂಡ ಅನ್ಸ್ಟೇಬಲ್ ಅದಾವೆ. ದೇ ಗೋ ಥ್ರೂ ಬೀಟಾ ಮೈನಸ್ ಡಿಕೆ. ಸೊ ದಿಸ್ ಎಲಿಮೆಂಟ್ ಫಾರ್ ಬೀಟಾ ಮೈನಸ್ ಡಿಕೆ ಒಳಗ ಪ್ರೊಸೆಸ್ ಹೋಗ್ತಾವ. ಇವು beta plus decay. So, are clear about the odd nuclei? Means the nuclei having the odd number of nucleons, that is nothing but odd atomic mass number. Is that clear? If you go for the case 2, even nuclei, that is case 2, if A is even, A ಯಾವಾಗ even ಆಗ್ತೈತ್ರಿ? A even ಆಗೋ ಪಾಸಿಬಿಲಿಟಿ ಅದ. ಇಲ್ಲಿ ಎರಡು ಟೈಪ್ ಇವನ್ ಆಗ್ತವೆ. ಒಂದು ಇವನ್ ನ್ಯೂಕ್ಲಿಯೈ ಇದ್ರೂ ಕೂಡ ಇವನ್ ಆಗ್ತೈತಿ, ಒಂದು ಆಡ್ ನ್ಯೂಕ್ಲಿಯೈ ಇದ್ರೂ ಕೂಡ ಇವನ್ ಆಗ್ತೈತಿ. We get this A as even for both odd number of neutrons, odd number of protons. This is going to be even. But then if it's a even number of protons, then even number of neutrons, also we get even. But so this is also going to be even. What about this term? What about the delta part for this odd? If both are odd, what is the delta here? For this delta is going to be negative. So what about if even is delta is going to be positive? Then you can expect here two parabolas. Here we get two parabolas. We get two parabolas. Therefore, one is one with A with Z with A. Then we get that one is alpha A plus beta times of Z plus gamma times of Z square. One is minus delta, for this is for even. Then the same expression M2 of Z with A, we get that one as alpha A plus beta times of Z minus plus gamma times of Z square plus delta. This is for odd. So generally we write this one as minus plus. Remember, this is not a plus minus. In M, we have taken that one as minus plus. So, minus of minus substitute ಮಾಡಿದ್ರೆ plus ಬರ್ತೈತಿ. Minus of minus, so plus of minus substitute ಮಾಡಿದ್ರೆ minus ಬರ್ತೈತಿ. ಈಗ minus substitute ಮಾಡಿದಾಗ even ಅಂತ ಕರೀರಿ, substitute ಮಾಡಿದಾಗ odd ಅಂತ ಕರೀರಿ. Actually ಅದರ ವ್ಯಾಲ್ಯೂ ಡೆಲ್ಟಾ ವ್ಯಾಲ್ಯೂ ಪಾಸಿಟಿವ್. ನಮಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಒಳಗೆ ಏನದ ಮೈನಸ್ ಪ್ಲಸ್ ಐತಿ, ಪ್ಲಸ್ ಮೈನಸ್ ಇಲ್ಲ, ರಿವರ್ಸ್ ಅದು. ಅದರ ಸಂಬಂಧ ರಿವರ್ಸ್ ಬರ್ತದೆ. ಓಕೆ, ಇಲ್ಲಿ ಗ್ರಾಫ್ ಹೆಂಗ್ ಬರ್ತಾವ ನೋಡ್ರಿ. ಸೊ if you look at the graphs like this, then this is Z, ಇದೇನಿದು ಮಾಸ್ ಆಫ್ ಇನ್ನೊಂದು Z ಕಾಮ ಇದು. ಎರಡು ಪ್ಲಾಟ್ ಬರ್ತವೆ, ಎರಡು ಪ್ಯಾರಾಬೋಲಾ ಬರ್ತವೆ. is above, ಹಿಂಗ್ ಬರ್ತೈತಿ, ಇನ್ನೊಂದು ಕೆಳಗೆ ಬರ್ತದೆ ಲೈಕ್ ದಿಸ್, ಹಿಂಗ್ ಬರ್ತದೆ. ಹೌದಾ, ಪ್ಯಾರಾಬೋಲಾ ಬರ್ತವೆ. ಸೊ So these are the two parabolas corresponding to this one. ಮೇಲಿರೋ ಪ್ಯಾರಾಬೋಲಾ ಯಾವ್ದು ಇರ್ಬೋದು ಹೇಳ್ರಿ? ವಿಚ್ ಇಸ್ ದಿಸ್ ಪ್ಯಾರಾಬೋಲಾ ಇಸ್? ಕೆಳಗಿರೋ ಪ್ಯಾರಾಬೋಲಾ ಯಾವ್ದಾಗ್ತತಿ? It is for even, isn't it? Because delta ಅದನ್ನ ಕೆಳಗೆ ಶಿಫ್ಟ್ ಮಾಡ್ತೈತಿ. Then ಇದು ಮೇಲಿನ ಗ್ರಾಫ್ ಎದರ್ದಿದು? It is for odd order. Okay, odd order. Then ನೋಡ್ರಿ, ಇಲ್ಲಿ ಕೂಡ ನಂಗೆ ಇಲ್ಲಿ ಕೂಡ ಏನು ವರ್ಟೆಕ್ಸ್ ಒಳಗೆ ಲೈ ಆಗ್ತೈತಿ. This element is always most stable. Just you have shifted your masses change again. Mass shift again. If you look at this, what is the difference between this one? In the health difference entry. Okay, if I take another one element here, another exact element here. So what is the difference between this one here to here? See, vertical mass difference between the two parabola is always vertical mass difference between two parabolas. ಎಷ್ಟು ಬರುತ್ತೆ? Can anyone tell me? What is the vertical mass difference? If you take, see, ಇರುವಂತ ಎಲಿಮೆಂಟ್ ಒಂದು ಏನೋ ಅಂತ ತಗೋರಿ, m1 ಅಂತ ತಗೋರಿ, m2 ಅಂತ ತಗೋರಿ. ಡಿಫರೆನ್ಸ್ ತಗೋರಿ ಏನ್ರಿ ಎಷ್ಟು ಸಿಗ್ತದೆ ನಿಮಗೆ ವ್ಯಾಲ್ಯೂ? Because for these two elements, see, these two elements is same. Sorry, that is same, isn't it? Which is the element that it is z0. So vertically ನೋಡಕ್ ಹೋದ್ರೆ ಅಂದ್ರೆ ಅದ್ರದ್ದು ಎಕ್ಸಾಕ್ಟ್ಲಿ ಕೆಳಗಡೆ ಇರುವಂತ ಎಲಿಮೆಂಟ್ ಏನಂದ್ರೆ ಸೇಮ್ ಇರ್ತದೆ. ನಂಗಿದ್ರೆ ಎರಡು ನೋಡು ಮಾಸ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಾಗಬಹುದು? And it's completely applicable for only one A. ಒಂದ ಏಕ್ ಅಪ್ಲಿಕೇಬಲ್ ಅದ, ಅದು ಇವನ್ ಅಂಡ್ ಆರ್ಡರ್ ಒನ್ ಅದ. ಬಟ್ ಆರ್ಡ್ ಆರ್ಡರ್ದಿಂದ ಫಾರ್ಮ್ ಆಗಿದೆ, ಇವನ್ ಅಂಡ್ ಫಾರ್ಮ್ ಆಗಿದೆ, ಡಿಫೆಂಟ್ ಆಗುತ್ತೆ. ಏನು ಸೇಮು, ಜಡ್ಡು ಸೇಮು. ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ ಎಷ್ಟು ಬರ್ಬೋದು ಹೇಳ್ರಿ? ಇಟ್ ಬಿಕಮ್ಸ್ 0 or 2z, 2 ಡೆಲ್ಟಾ. ಸೊ ಎರಡೂ ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಸಿಗ್ತದೆ ಗೊತ್ತಿರೋದು 2 ಡೆಲ್ಟಾ ಡಿಫರೆನ್ಸ್ ಸಿಗ್ತದೆ. ಬಿಕಾಸ್ ಏನು ಸೇಮ್ ಜಡ್ಡು ಸೇಮ್ ಅಂತ ಅಂದ್ರೆ ಎರಡೂ ಡಿಫರೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಆಗೋದು ಇಲ್ಲಿಂದ ಡೆಲ್ಟಾದಿಂದ ಕ್ರಿಯೇಟ್ ಆಗ್ತದ್ರಿ. ಮೊರೋವರ್ ರಿಮೆಂಬರ್, ಇದು ಕೆಳಗಡೆ ಇರೋದು more stable ಅಥವಾ ಮೇಲೆ ಇರೋದು more stable? Anyone? So odd nuclei are stable or even nuclei are stable? Evens are more stable than odd. So odd nuclei is going to get decay to even by the process of beta plus decay. Here these are going to get decay through beta minus decay to get more stability. Is that clear all? Yes. Okay. So this is what is exactly parabolas and their decay process depending on this atomic mass values, whether it is even or whether it is odd. The even nuclei, total mass of the nucleus can be defined with the two terms. One is odd nucleus and even nucleus. So we get two parabolas here because of the parity. This is what is this delta is defined as? Delta is defined as pairing energy term. Pairing energy term. Is that clear? So these are the two parabolas. Just you need to remember. ಮೇಲಿಂದ ಯಾವ ತರ ಅದ, ಕೆಳಗಿಂದ ಯಾವ ತರ ಅದ, ಏನದ ಅಂತ, ವಿಚ್ ಇಸ್ ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಅಂತ ಕೇಳ್ತಾನೆ. ಆಲ್ವೇಸ್ ಪ್ಯಾರಾಬೋಲ್ ಅದ ಏನು ವರ್ಟೆಕ್ಸ್ನೇ ಬರುತ್ತೆ ಅದು ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಆಗಿದೆ. ಎಲ್ಲ ಯಾವ್ದೋ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಕೊಟ್ಟಿರ್ತಾನೆ, ಎಕ್ಸ್ಪ್ರೆಷನ್ ತಗೋರಿ, ಅದನ್ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡ್ರಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಜಡ್ಡು. ಯಾವ ಜಡ್ ಒಳಗಡೆ ಅದು 0 ಬರತ್ತದ ನೋಡ್ರಿ, that you get as most stable. Okay, next is condition for beta decay. Condition for beta decay. So ನೋಡ್ರಿ ಇವನ್ನೆಲ್ಲ ಡಿಕೆ ಪ್ರೊಸೆಸ್ಗಳು ನೋಡ್ಕೊತವನು. ಈಗ ಆಲ್ರೆಡಿ ನಾ ಬೀಟಾ ಪ್ಲಸ್ ಅಂಡ್ ಬೀಟಾ ಮೈನಸ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡೀನಿ. ಹಂಗಿದ್ರೆ ಇಲ್ಲಿ ಬೀಟಾ ಪ್ಲಸ್ ಡಿಕೆಗೂ ಮತ್ತು ಬೀಟಾ ಮೈನಸ್ ಡಿಕೆಗೆ ಏನು ಡಿಫರೆನ್ಸ್? ಕಂಡೀಷನ್ ಫಾರ್ ಬೀಟಾ ಡಿಕೆ. ಜನರಲಿ ಬೀಟಾ ಡಿಕೆ ಅನ್ನ ಬೀಟಾ ಡಿಕೆ ಅಂತ ಕರಿತೀವಿ. ಇದ್ರಾಗ ಎರಡು ಟೈಪ್ ಬರ್ತಾವ. ಒನ್ ಇಸ್ ಬೀಟಾ ಮೈನಸ್ ಡಿಕೆ, other one is beta plus decay. What is the condition for beta minus? What do you mean by beta minus? Beta minus is nothing but emission of into the electrons. Electron emission ಗೆ ನಾವು beta minus ಅಂತೀವಿ, positron emission ಗೆ beta plus ಅಂತೀವಿ. So for example, ಯಾವುದೋ ಒಂದು ನ್ಯೂಕ್ಲಿಯೈ ಅದ atomic number Z, mass number as 8. If it is going under beta minus decay. Beta minus decay means one electron will be minus ಆಗ್ತದೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಮೀನಿಂಗ್ ಏನು, ಇದರದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಕ್ರೀಸ್ ಆಯ್ತು ಒಂದು ಯಾವುದೋ ಒಂದು ಅಟಮ್ ಒಳಗಡೆ ಅಂದ್ರೆ ಏನು ಚೇಂಜ್ ಆಗ್ತೈತಿ, ಎ ಅಂತೂ ಚೇಂಜ್ ಆಗಂಗಿಲ್ಲ, ಚೇಂಜ್ ಆದ್ರೆ ಜಡ್ ಚೇಂಜ್ ಆಗ್ತೈತಿ. ಅದರ ಮೀನಿಂಗ್ ಏನು, ಜಡ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ನಂಬರ್ ಆಫ್ electrons or number of protons in the nucleus. So Z is nothing but number of electrons. If it goes under only one electron decay, beta minus decay, then the element will change to this plus one. Isobar either. Bars are same, these are same, different parts are there. This can be written as there is a change in Z, therefore there is a emission of electron. Electron mass ilri, massless ಅಂತ ಹೋಗ್ತೀವಿ, ಅದು ಚಾರ್ಜ್ ಅನ್ನು ತಗೋತೀವಿ -1. Then it releases a energy Q. Right? Therefore, just look at this. Always new electron nuclear reaction ಬರಬೇಕಾದ್ರೆ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎ ಅಂಡ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಜಡ್ ಮೇಲೆ ಫೋಕಸ್ ಮಾಡ್ತಾರೆ. ಜಡ್ ಅದ ಅಂತಂದ್ರೆ ಇದು Z -1 -1, Z +1 -1, total becomes Z1. But this Q is defined as energy difference. Energy that is going to be released. So energy hang release agada ಅಂತ ಕರಿತೀವಿ. That Q can be calculated. Yes, Q is nothing but A with same ಮೊದಲ ಒರಿಜಿನಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಅದ, ಅದರೊಳಗಡೆ ಪ್ರಾಡಕ್ಟ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿದ್ದು A ಮತ್ತು Z+1, ಜೊತೆಗೆ ಮಾಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಕೂಡ ರಿಲೀಸ್ ಆಗಿದೆ. This is going to be defined as energy which is released during the nuclear reaction. ಮಾಸ್ ಅದ C² ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಸಿಗ್ತೈತ್ರಿ, ಎನರ್ಜಿ ಸಿಗ್ತೈತಿ. This is defined as ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಸ್ ಅಂತ ಕರೆದು ನಡೀತೈತಿ. ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಸ್, ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಸ್ ಗೆ C² ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ we are going to get the total energy. Now remember, for beta minus decay to occur, so beta minus decay to occur, so we need to have delta Q should be greater than 0. Remember, the mass of the reactant is greater than mass of the product. So initial ತಗೊಂಡಿದ್ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಮಾಸ್ ಏನಿರ್ತೈತಿ ಇದಿರು ಪ್ರಾಡಕ್ಟ್ ಮಾಸ್ಗಿಂತ ಜಾಸ್ತಿ ಆಗಿರ್ತದೆ, ಜಾಸ್ತಿ ಇರಬೇಕು ಎಲೆಕ್ಟ್ರಾನ್ ಮಾಸ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು. In terms of nuclear mass or condition ಏನು beta minus ಆಗಬೇಕಾದ್ರೆ this should be, its initial mass should be greater than its product mass. And even if you look at this, see, and if I take this, I have taken this one, right? The expression ನಾನು ಹಿಂಗೂ ಬರೀಬಹುದು. ಮಾತ್ರ ಕೊಡೋ ಕಡೆ ಒಂದು Z times me ಅನ್ನು ಆಡ್ ಮಾಡ್ರಿ, ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಜನರಲ್ ಆಗಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ್ರೂ if I take this A with M with Z plus Z times of Me, what is this gives? ಏನು ಸಿಗ್ತದೆ ಅಂದ್ರೆ ಟೋಟಲ್ ಅಟಾಮಿಕ್ ಮಾಸ್ ಅನ್ನು ಕೊಡ್ತದೆ. This gives, this is the nuclear masses. In terms of nuclear mass, here it is atomic mass. Okay, so it is going to be, if I add this number of electrons, because it is only nucleus cluster, this part is only for the nucleus. Okay, this part is only for the nucleus. ಅದರ ಜೊತೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಆಡ್ ಮಾಡಿದ್ರೆ ಮಾಸ್, ಅಟಾಮಿಕ್ ಮಾಸ್ ಬರ್ತದೆ. This should be greater than mass of the product, that is Z+1 with A, then plus already electron ಒಂದು ಐತಿ, so ಮತ್ತೆ ಏನು ಮಾಡಿ Z times of Me ನ electrons ಆಡ್ ಮಾಡಿ ಟೋಟಲ್ ಏನು ಕೊಡ್ತದೆ, ಪ್ರಾಡಕ್ಟ್ atomic mass ಅನ್ನು ಕೊಡುತ್ತೆ. Therefore, by using this, I can rewrite mass of atomic mass of the reactant should be greater than atomic mass of the product. So this is given as atomic mass, in terms of atomic mass. Therefore, this mass A Z minus mass with Z+1 should be greater than 0. That mass difference between these two should be greater than 0. For energy released ಏನಾಗ್ತದೆ ಇಲ್ಲಿ, ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಅದಕ್ಕೆ ಏನಿರ್ತೈತ್ರಿ, ಪಾಸಿಟಿವ್ ಇರ್ತೈತಿ ನೋಡ್ರಲ್ಲ. ಬಿಕಾಸ್ ಡೆಲ್ಟಾ ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ Q is equal to ಏನಂತ ಕರಿತೀವಿ, ಡೆಲ್ಟಾ MC². ನ್ಯೂಕ್ಲಿಯರ್ ಮಾಸ್ ಡಿಫರೆನ್ಸ್ ಏನದ ಅದು ಪಾಸಿಟಿವ್ ಆಗಿತ್ತು ಅಂದ್ರೆ ಎನರ್ಜಿ ಕೂಡ ಏನಾಗಿರ್ತೈತಿ positive ಆಗುತ್ತೆ. Therefore it is a Q is positive here. Okay. So as of now time is over. 8 ಆಯ್ತು.